Good morning, Tehmina Khan is here in TKMaths S1. In today's video, we will continue studying A-Level Mathematics M1, lesson number 2, distance, velocity and time, acceleration. And today we are covering the sixth aspect of this, which is graphical representation. And it is lesson 2.6. The rest of the videos, the link of the videos is in the description below. So let's continue. Graphical representation. This video will be little lengthy because I want to cover all the aspects of graphical representation in one video. I don't want to break it into two. So in this video, we will talk about displacement time graph and multi-stage problems, then velocity time graph and multi-stage problems, and then graph with discontinuity, which is mostly a challenge most of the time for students. So first of all, it will be the explanation of different types of graph here. So let's study the displacement time graph and multi-stage problem. The gradient of the displacement time graph is equal to the velocity. And you know how to find out the gradient. You know the gradient formula here. We are talking about here straight lines. So it is y2 minus y1 over x2 minus x1. You can use that also. So look at this left-hand side green graphs. If it is a distance time of displacement time graph and body is stationary, then the line will be straight like this. Okay, you have to understand all these very well. For uniform motion, for example, car is moving with the speed of 2 meters per second, and that is the speed you can see when you travel in the speedometer. Then you represent this by slant line like this. For non-uniform motion, like speed is increasing, you keep increasing the speed, then in the distance time graph, the graph has this shape, little curve going upward. And if speed is decreasing, you are already at the high speed and gradually you are slowing it down, but it is not a constant motion, it is decreasing and decreasing and decreasing, then you represent it by this type of curve. So now let's look at the right hand side of this. If you look at this purple line and this red line, which is represented by A, both have slant like this. So what is the difference between them? The only difference is the more slant mean the speed is high. Don't forget, I'm talking about displacement time graph here. And for this part B, I have just explained to you here, it means object is stationary. Time you can see is increasing from 4 seconds to 7 seconds, but displacement is still at 7 meters from wherever you are. So it means it is stationary, body is at rest. And if you look at part C, the steady speed returning to the start. It means you are coming back. So when you will come back here, you are back to the same position. Okay, so you understood these aspect of it. Now let's see. And if it is totally new thing for you, you have not studied in physics, but depending what subjects you have, then you have to revise it or go through it 2-3 times to remember it, right? So what we will do, we will just see a quick example of this. I have taken here 4 scenarios, A, B, C, D, and we will represent it with the help of sketches. And we will sketch what? Displacement time graph. So it is drawn here, but when you will read the situation, you try to make it up in your mind, or you can take a piece of paper and pencil and sketch it. Okay. In each case, consider north to be the positive direction. So if we talk about north, you will take it as positive. If we are talking about south, it will be negative. If it is east, which is like this, it will be positive. If it is west, it will be negative. Okay. Now, scenario A. Bob leaves his home and heads north at a constant speed of 3 meters per second for 10 seconds. So in the displacement time graph, how will you sketch it? I hope you have made the sketch in your mind or on the paper, depending. You can keep the video on pause also. So it is a displacement time graph. He is going with the constant speed of 3 meters per second for 10 seconds. So that's why time here, if you see, is 10 seconds. and speed is constantly increasing, so slant line. But how did we get this 30? It is not written here. Yes, for constant speed, the formula you remember, speed is equals to distance over time. So distance is equals to speed into time, right? You remember this formula. So this is the formula used. So 10 into 3 is 30. So that's why it is. By the way, for displacement we use S. That's why symbol S is used. But I'm using the word distance here. It's okay. So it is 30. That's why we stopped at 30. Correspondence to 10 seconds. Now part B. Jenny is 30 meter north of home. So she's already 30 meter away from home and walks at a constant speed of 1.5 meter until reaches home. Now what will happen? Okay, so let's see here. Because she was 30 meter away from home, so she was here. As she's coming towards home, so she will come like this. And how will you calculate this distance? The time that she will reach in 20 seconds. Again, you will use the same formula. So time is equals to displacement over time, or in this case distance and displacement is same. So it is 30 divided by 1.5. So you will get it. Right. Now third scenario, which is C. Again take few seconds. Okay, so you understood. Rio is sitting still at a point 10 meter north of his house. So he is sitting there. For how long we don't know. So what will happen? It's like a stationary case, right? So a straight line. And because he is in the south, so from the house, south is downward, like I told you. So it will be minus 10, right? And a straight line because it is stationary. He's not moving anywhere. Situation D. Nina is 300 meter north of her home. Okay, north is above the 0 point. She drives south at a constant speed of 10 meter per second, passing her home until she travels a total of 500 meter. So what comes in your mind now? Little challenging, but not difficult. It's challenging, so it is little difficult. Okay, so let's see. So what happened? She was here, right? Because it is a displacement time graph, she is coming back with constant speed of 10 meter per second. So she will come all the way till here. When she will reach here, it means she is at her home, but passing her home until she travels a total of 500 meter. So 300 meter she has already covered from here. So she will go further down with 200 meter. That's why it is minus 200. And how are we calculating these timings? With the help of same formula, speed is equals to displacement over time. So I hope these situations are clear to you. So let's move on. If you will have any question, you can put it in the comments box, and I will explain it to you. Now let's see the situation here. If this video will get very long, then I might break it up into 2 parts. Okay. Now we are talking about velocity time graph and multi-stage problem. In the previous case, we have discussed displacement time graph. First of all, the explanation, and then I will take the situation and the questions. So the scenario is an athlete runs for, he starts at rest. Now important point, start at rest and gradually increasing his speed over the what? First 30 seconds. So what you will draw here? Before maintaining the same speed of 5 meters. So when he started from rest and for 30 seconds, he reaches to which speed? 5 meter per second, right? So that part will be represented by this straight line, okay? Slant line. After that, it is written maintain the same speed for 60 seconds. So first it is 30 seconds. 30 plus 60 is 90. So until 90 seconds, what will happen now? The line will be straight, this straight line. Okay, so first it was this part. For 30 seconds he was speeding up and reaches to the velocity of 5 meters per second, and then for 60 seconds he continued the same speed, running with the same speed. Then he gradually reduces his speed until coming to rest another 30 seconds. Now when he is reducing the speed, it means it will come like this, right? What is written further? To another 30 seconds and until he come to rest. So it means now the line will come and touch the time axis here. Is this clear? So this is your third part, and this is for what? 30 seconds later. So 60 plus 30, 90 plus 30 is 120. Okay, I'm not showing you the rest of the part, but it will be 120 here. Now let's see what is the next part. The athlete then returns to his starting point. Now please understand, in velocity time graph, when this is the situation on the ground, what it is happening. Suppose the runner, just a second. Suppose the runner starts from here, speeding up, fine, till here he speeded up. Then he continue with the same speed, fine. And then he slows down and come to rest. So these are the three segments, 1, 2, 3, which are represented here by these lines. You understood? So right now the athlete has stopped at this point, which is represented by here. Now what is written here? The athlete then returns to his starting point. Now he is coming back. Okay, so he returns to his starting point by increasing his speed quickly at the start and continually trying to increase his speed for 90 seconds. So for next 90 seconds, he keep increasing his speed. How we will represent it? See here. Because his speed is continuously increasing, it is not a constant speed. That's why it is a curve line here. Not line, curve path. You understood? This word is speeding quickly at the start and continuously trying to increase his speed. And that's why it is a curve path, right? And it is happening for 90 seconds. So 120 plus 90 is 210. That's why he has reached till here. After that, what happened? But only managed to increase it by smaller and smaller amount, peaking at 6 meters per second. So it means because he was slowly increasing and he reaches to 6 meters per second, we are representing it by -6. What is the reason? Because it is in this direction now. He is coming back on the ground, okay, from where he started. He then slows down over 10 seconds before coming to rest at his starting point. So 210 plus 10 will be 220. So this point should be 220. And now what is happening here? He then slows down over 10 seconds before coming to rest. So now let's see what happened. You understood? Because now he is not saying K increasing, but slowly slows down over 10 seconds. So now this is the graphical explanation of multiple stage of velocity time graph. So now the gradient of the velocity time graph is equivalent to the acceleration of the object. Okay, so if I want to see the acceleration here and it is not given, I will simply apply the gradient formula and I will get it. Okay, now this example. So I think after this example, I will put the video on pause before going into the graph with discontinuity. That we will do in the next video. So sketch the velocity time graph for the information given below. In each case, take upward to the positive direction. The same situation which I explained in the previous case. A ball is thrown up in the air from the surface of a pond. Now suppose this is the pond, right? And ball is thrown upward with initial velocity of 20 meters per second. It accelerates downward under gravity. We know it slows down by the 10 meters per second. In mechanics, we use 10, not 9.8. Once it has reached the highest point, it means it will reach here. What will happen here? It will stop, right? And then it will fall back. Once it has reached to the highest point, it falls until it hits the surface of the pond again. Okay, so it will hit again. Now you must know one rule of science or physics here. The velocity with which you will throw it up, when the object comes down in free fall, when it reaches to the same point, it has the same velocity. Okay, so if I'm talking about here plus 20, I will talk about here minus 20 because the direction has changed, right? And then after that it goes underwater, and underwater what happens? Things slows down, the velocity slows down if there is no external force. Under the water it continues to accelerate with constant acceleration 1 meter per second for 1 second. Okay, so now let's see the graph of this. The first part, when object is thrown up, right? When it is thrown up, here, let me delete this and write here again. So when it was thrown up, it is going up and up and up, and then it slows down and come to 0. And that's why this is the point on the time when the velocity is 0, right? Because it is slowing down, so that's why it is downward direction, the velocity. Okay, but what time it will be, how will you calculate it? If I want to calculate this, I can use the gradient formula I told you. So the point here is 0, 20, and here it will be, I don't know the time, comma 0, which I have taken here. So I will calculate it will be 2 seconds. So at this point it will be 2 seconds. It means in 2 seconds it has reached here. So what do you think, how much time it will take to come down again? Absolutely right, same time it takes. So again it will take 2 seconds. So total it will take 4 seconds to go up and come back to hit the surface of the pond. We are not talking about the case when it will go inside it right now. So now what will happen next? So next, this as part of the graph is representing this downward motion, right? This motion, this part. After that it is slowing down. Okay, after that it is slowing down from here. So what will happen now? This part of the curve, you see, this one, small part of the curve. How did we get 5 and how did we get 21? I have already told you 4 here, right? 4 I have already explained to you, it is double of the time. And why it is minus 20, that also I have explained to you, because that is the time when the ball or the particle is hitting the surface of the pond when it came back. After that it is written constant acceleration 1 meter per second for 1 second. When it is saying for 1 second, it means I will only go 1 second more in the graph, in the sketch. So 4 plus 1 is 5, and acceleration is what? 1 meter per second square. So it will be 20 to 21, right? So next question is you have to answer seeing this graph. Okay. So can you find out the height in this case if I give you a little time? If you study the graph shows the motion of the ball when it throws upward. We can see here it is slowing down in the air until it hits the ground. So it means the ball is going up and coming back. And this is the situation when it hits the ground, right? And this is the point when it is at the highest point and stops and come back. Find the height above the ground from which it was thrown. What will you do? You know the area under the curve in the velocity time graph gives you the distance, right? So you can find out this distance if you want. You know this is 0, 10. You know this point is 1, 0. And this point is t, minus 1 point, 15. So let's find out the acceleration because nothing is given here, right? So with the help of the formula, gradient formula, because the gradient of the velocity time graph will give me acceleration, or straight away the gradient of the whole line is same throughout. So what can I do? I can find out the gradient between this and gradient between this, right? Then I will do what? Let's see here. I'm applying gradient formula y2 minus y1, okay? 10 minus 0 over 0 minus 1 equals to, now applying gradient formula between the next 2 points, 0 minus 15 divided by 1 minus t. So let's quickly solve it. Minus 10, that was understood also because it was a free fall, but still I'm doing it just to show it to you. 15, 1 minus t minus 10 plus 10t equals to 15. 10t is equals to 15 plus 10 is 25. T is equals to 2.5. Right? So now I know this time is here. Let me raise it from this point so that, so that I can draw further. Just 1 second. Okay, so now I know this point is 2.5. I have just calculated. And I know area under the curve is the distance. Agreed? So let's calculate the distance here. First part, the distance is what? Area of a triangle. Half into 1 into 10. It is 5 meter, right? And then for this part, it is half into 2.5 minus 1 is 1.5, right? I'm calculating this length. And then this is 15. So what it will be? Let's calculate quickly on the calculator. You can do mentally also. .25. So now if I minus this above distance covered is 5 and this distance is 11.25. Now if you read the question, find the height above the ground from which it was thrown. So what does this show? That suppose you are standing somewhere here and this is your ground, right? This is your ground and this is from where you have thrown the ball up. So now this point is here, okay? So it means when you calculate this distance, it is 5. And from here till here mean from this point till this point, it is what? 11.25. This is the meaning of the graph, right? You have to find out what is this distance from where you have thrown the object up, which was above the ground. So simply 11.25 minus 5. It will be 6.25 meter. So this is your answer. So I hope you understood it. In the next video, we will study the graphs which are talking about discontinuities. Very, very important concept. I would have, I decided to explain here, but it is taking longer. So thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.